I was in the old StreamYard, that's why I didn't see you here. Now I'm in the right one. I was in the old StreamYard.
Hello everyone and welcome to No Assembly Required, Replit's monthly pedagogy workshop, where once again we're joined with the amazing Bram Moreinis. Hello Bram. No Assembly Required, Replit's monthly pedagogy workshop, where once again we're joined with the amazing Bram Moreinis. Hello Bram.
Lots of delay here.
There's a lot of delay, Bram. We can hear everything that you can hear as well.
Lots of delay here.
There's a lot of delay, Bram, but we can hear everything that you can hear as well.
Lots of delay here.
What I may do very quickly is, Bram, I'm just muting you a second because we're getting a lot of feedback from that. Is it okay if you close it down and open it back up, see if we get a better connection? Because otherwise it's going to be very difficult for us to have a conversation tonight. Cool. Well, whilst Bram sorts himself out, let's have a chat about what we're doing tonight. Tonight, we're going to be looking, I say tonight, it's tonight for me. It's an international audience. You could be absolutely anywhere. So what I'm hoping is that whichever time zone you're in, you're going to enjoy tonight looking at how we go from idea to flowchart to actually working code in Replit with some classic ideas. How are we doing, Bram? Any better? Flowchart to actually working code in Replit with some maybe this isn't going to work tonight. You never know. Actually working code in Replit. What? Right, maybe we just need to have a signal where we just switch over and hand over to each other. What do you think? We'll see. I'll get started talking, Bram, and you can feel free to jump in when you can. Okay. So apologies for everyone as we're getting this this lovely offset here. We've never had such terrible technical problems, honestly. Hopefully Bram will sort himself out as we go. I say that. I hope it's not my technical problem, because fingers crossed, new internet speeds. So hopefully that's doing better than before. I just want to start off by jumping over today and having a look at some of the new stuff on Replit this week, because it is worth taking a look. Now, today we launched a brand new curriculum. If you've got Teams for EDU, remember you can bring any of these curriculum content in for free. We have launched one of our curriculum jam winners, which was Python APIs from Mission Encodable. Now, Mission Encodable are a pair of teenagers who are keen to teach everyone, and especially their peers, how to program well in Python. They've got some brilliant tutorials on their own websites, but they brought some of them to us, and we've got a series of good lessons on using APIs with Python. Now, this is really, really nice, actually, because this allows you to connect with real data. And you may have done a little bit of 100 days of code recently, but there are things your students can do, like generating a bunch of dad jokes and getting it text to you, or even using the Spotify API to bring information in that way. Well, Bram's back. Let's see. How's it going, Bram? Any better?
So I am now not looking at the actual live stream. I'm just looking at StreamYard. Does that work for you?
That sounds good. That's better. I think it was on about a 10-second delay. It was a bit awkward.
So now it's good?
No, it's perfect now. Thank you. That's
I don't know how I'm going to share a screen, but we'll see how it goes. All right, good. Sorry. Back to you.
You should be able to at the bottom in StreamYard, but I think
I got it.
Most things up for us anyway, so don't worry. Well, behind the scenes of our technical issues there, but the wonderful Bram is below me. And I do call him the wonderful Bram because the last workshop he led for us was absolutely fantastic and really got us excited. I think we were both quite excited afterwards, which is why we're doing another one. So Bram, thanks for being here and thanks for running this with me today. I was just talking about the new curriculum that we've added to the Curriculum Hub. The Python APIs one is great if you want to push students in like a realistic direction. But we've also got a bunch of stuff from Stacks, which is a Scottish teachers advancing computer science, and we've got all of their curriculum on here, which they've very kindly popped on there, and they share freely. There's a bunch of stuffs in there, from Python to HTML to SQL to Java, and as you can see, hundreds of projects in most of them. So there's a bunch of cracking stuff on the Curriculum Hub if you've not been there recently. And I do also want to give a shout out to Bounties, because we've all got those students in our classes that are a little bit ahead of everybody else. Bounties is a way for them to make money by bidding to take on programming projects. It's real experience, it's good for the portfolio, and of course, they can use those cycles to pay for boosts and power-ups in Replit itself to make it better for them. So if you've got a student that is flying and really ahead of everyone, or if you've got a group of students that you think would benefit from doing that and building their portfolio, point them in the direction of Bounties and get them to sign up, because it's a great little way of extending their knowledge. Brilliant. Right, Bram, hello. Let's have a chat before we get started. How are you?
So, you sent me over to ChatGPT, right? I was having a little fun with it today, and one of my students is converting a tic-tac-toe program that he wrote in JavaScript to object-oriented JavaScript.
Oh, cool.
And, this is his first attempt to do anything with object-oriented JavaScript after having watched a Pluralsight, video course. Mm-hmm. And I decided to help him out. And I just went into ChatGPT and I said, give me a tic-tac-toe program and open open object-oriented programming JavaScript. And the thing just bloop, wrote the whole thing. Now, it was, incomplete, of course, but the whole structure was there, down to checking for diagonals and checking for rows and columns. And I just handed it over to him to just play with. But wow, that thing is insane.
I think between that and Ghostwriter, I'm doing a lot of my work now with AI. It's brilliant.
You mean you're not doing your work with AI?
Well, I'm spending most of my time just seeing if it'll work on prompts and generate things for me. But it's been really good. For instance, the other day I was doing did a piece of work on looking at modern JavaScript, because I learned JavaScript when it was ancient. So a lot of my techniques are a bit old-fashioned. So I sort of just went, tell me about modern JavaScript techniques and give me examples of the old style and the new style. I learned quite a lot. The only problem with it, it's one of those, it feels a bit like, the kid in your class that's very, very confident, but doesn't quite know everything. It feels a bit like that, because it will tell you in a very convincing way a fact that is incorrect.
Mm-hmm. So yeah, I asked it to write a poem about the hopelessness of climate change using E. Cummings. There was rhyme, there were capital letters, there was punctuation. I'm like, come on, guy.
Tony in the chat has said that ChatGPT has huge implications for education.
Yeah.
And I think
positive and negative.
Oh yeah. I think the first thing I'd say is, show this to the students that because The other departments in the school are not going to clock onto this as quickly as the computer science students. So just remind them that it's not quite the most ethical thing in the world to submit a ChatGPT written essay.
Or program.
Or program, yeah, certainly. But with that said, it's a great thing. It's a great thing to play with at the moment, and it seems to be getting better. I managed to convince it the other day that it was a music journalist to get it to write about music because it was refusing because it was an AI bot. And this morning it wouldn't do it. It wouldn't role play with me at all. So here we go. Right.
Well, my principal irritated me, so I asked it to write a letter of resignation from a middle school teacher and I gave it the name of the school, and it wrote the whole thing right there. I could have just emailed it in my fit of pique, but calmer heads prevailed.
That is a little scary, isn't it? Because when you're riled up, you can get the text of it much quicker than you could before.
No, and it was so calmly written. Like it was like, while I've really enjoyed my time here and learned a lot with all of your support, I'm feeling like it's time to move on. But I just wanted you to know that I'm going to be here to help all the students transition to whoever's going to take the thing was just, if I ever need to use it, that's where I'm going.
I think, yeah, that's much nicer than the ones I've ever had to write were. Right, Bram, should we get started? And I think
Sure.
We'll get started with the game that I usually ask my students to play. Is that all right with you? We start
Go
with
for
that?
it.
Cool. So we've talked a little bit about how we do this in class, and like I tend to have, I suppose, more consistent experience with this. Correct me if I'm wrong, Bram, but mainly because in the UK we have centralized exam boards, so they tell us what we have to teach, and then we have to find ways to make it interesting. And one of the things they constantly ask us to teach is search and sorting algorithms to 15-year-olds. So I'll pop a link to a REPL in the chat, which you're welcome to go and play. Bram, I'll send that to you in private chat as well if you need it.
Yeah, I was just thinking about what it would do to our session if I had to go back into that thing. All right.
Yeah, destroy it all. And what I'll do is I'll share my screen very quickly. This is the program that we often build when we're dealing with ifs and elifs. So, this is early on into the course. This is, GCSEs for us are 2 or 3 years, depending upon how the school sets it up. And this is the sort of thing that I'm doing maybe 2 or 3 months in, when we've just dealt with ifs, elifs, nesting and probably casting to make sure that we get integer values and stuff like that. Again, all this is very particular to Python because it's a weakly typed language. So it's a little bit different to if you're teaching Java, which is a bit more strongly typed. But at this point, I get them for homework or for a task or for an assessment to write a program that just does that higher or lower guessing game. In this case, it generates a number between 1 and 100 at random and asks you to guess. Now, the reason that's quite a nice thing to do is because it leads on very nicely to a classic search algorithm. And Bram, how are you doing? How many guesses have you gone for so far?
Oh, I didn't know I was supposed to start playing. I was waiting for some other instruction. All right, I'm starting now. All right.
Go for it. Can you share your screen from StreamYard or?
Oh, yeah, let's see if I can. Back to StreamYard, back to present, and then share screen, and share screen. And which screen? The one that says main pie, allow. All right. Of course. Are we good? All right, we're good there.
We're good.
So I was too low on my 50. I'm going to go up to 75. Too low. I'm going to go up to, let's see, 87. Too low. Okay, we're going to go to 90. 92. No, 91. All right, still too low. Gee, this program's really making it hard for me. All right, let's go to 95. All right, still too low. Holy cannoli. All right, 98. All right, too high. Thank God. All right, 97, and then 96, and there we are. 8 guesses. Well, I guess that's the most it would ever need me to do. So, all right, that's something.
Absolutely. Now, this is why I love this so much, because Tony in the chat has said that old school telephone directories used to be good for this as well. Yeah, totally. But I can't think of anything physical that would be the same at the moment. Maybe somebody else in the chat can mention something. But this, as a leap into something that's a bit more technical, is great, because Bram there, clearly being a cut above most people, did a binary search algorithm in his head. He went to the midpoint each time so he could very quickly get to it. Now, when students who don't know about these things or don't have, great logical powers early on do this, what it tends to be is some of them will do it naturally. Some of them will think that's the most efficient, and some will just guess randomly and hope for the best, pick a number they like. But this leads on to that discussion then about, is there a better way of searching? And Bram, your method was picking the middle number, yeah?
Yeah, until I got a little sloppy at the end. The numbers were too high for me to really do operations on.
Now, what works nicely as well is if you set the task between 1 and 1,000,000, the number is so big that students tend to freak out a little bit and don't apply as much logic. So they'll just start looking, they'll start randomly typing in numbers. And so when you show them somebody that is doing the binary search, you can have a good conversation about it. And one of the things that I tend to start with is talking about, well, in this case, then let's see if we can talk about how we'll structure this. And these are my actual teaching notes. Oh, sorry, Bram, I've got your stuff on the screen. Let me switch over. These are my actual teaching notes from when I actually do lessons. And this is something I start with. Well, what is an algorithm? Why do we care about it? And we talk about flowcharts. You can see there, Bram, it's very similar to the way you do it. And of course, this is a defined way that we have to do it in the UK. The exam boards tell us what symbols to use. And they also like pseudocode as well. But as I said last time, unlike in the real world, the pseudocode we have to use is not nice. It is prescriptive. It is based seemingly on Visual Basic, and it is horrendous. So students have to sort of learn this pseudo programming language, which isn't nice and they don't like doing. So we stick to flowcharts in the main because they are a lot stronger. And so we'll talk about then idea of, say, a linear search. And I will show them something like this, just an example of how we do a linear search. And this is the naive method. So I pick the student in the class that managed to go in an almost linear way. There's going to be one. There's definitely going to be one person that started at the beginning and tried to work their way up to 1,000,000. And we look, in this example, it's a bunch of letters. And we're going to start at the beginning and we're going to say, nope, nope, no. Oh, here we go. And the question naturally arrives then, well, okay, how do we build a linear search? And Bram, that's where I'm going to hand over to you, because suddenly flowcharts become really important.
All right. By the way, I've written a program that always tells you the exact number of times that you have, the exact time that you're going to find what you're looking for. It's always in the last place you look. No, just kidding. All right. So I've started a nice flowchart for people in Lucid, and I know you put that thing out to folks that said they should try logging into Lucid, and I'm going to put the join code here into our chat. Maybe you could transfer that over to, yeah. And I should then start seeing people show up, all the many people who are here, but at least maybe one person could show up on that thing. But now I'm going to go share my screen. So it said stop screen before, so I guess now I'll just start it again. Share screen, dink, and bop. Okay. So pretty much the same shapes that you're using. In Lucid Chart, you just basically drag the shapes out as you need them. And I just taught flowcharts today. So we have our, if I want to maybe, build this in front of people, I could. So we have our start, and then I'm storing. I talked to the students about input, output, processing, and storage. That's the level that we're at where we're talking about those things. And code.org's wonderful computer science discoveries has a great lesson in its first unit on input and output and processing and storage on what is a computer. So when I'm building the flowchart, I say, okay, so what do you think this thing is? This box that says value equal X. Well, that's storage, right? We've got a variable, it's got a name, and it's got a value. And the reason why it's a variable is that the name stays the same and the value always changes, or can change unless you're dealing with a constant. And what I do in my flowcharts is I always make the variables bold so that students can distinguish between what's a variable and what's not, kind of track them.
I like that.
So there
idea,
we've got
it. I never did that, and it's such a simple thing, and it makes a big difference. I think that really makes it more readable to me. So, you know, props for making it bold and making it clear.
Thank you. So, so here we've got our value, which is how David called it in his program. We've got a list of an array of n values. Start with index equal to 0, and if the list index is not equal to value, why would I have that not equal to there? Huh? Did I make a mistake?
I think you may have.
I think I did. All right. How horrible. Well, teachers know how to like do it on the fly.
Yeah, we always say this is on purpose, don't we, when we do it in front of our classes?
Yeah. Now, actually, this actually comes to a little bit of a point of art. I just use one equal sign when I'm doing my conditional, because this isn't code, and having two equals is a function of syntax in code, and we don't really need to use that here. As with pseudocode, you can put more or less code logic into your flowchart, but anything that makes the flowchart any bigger than it needs to be, on the other hand, maybe the students need to have the reminder, so it's up to you how you do it. But so, we've had a bunch of storage, and then all of a sudden we have some processing, and then, if we find a match, it returns the index, and if not, we end. Now, returning the index, it really should return the value, except that we already know what the value is, right? We already know what we're looking for, so all we really need to know is, where was it? Or maybe we should be counting the thing and figuring that one out. Now, the one thing that this doesn't have is any human input. So maybe what I want to do is have the human being enter the value, right? How would I do that? Well, I'm just going to take this thing and put it out of the logic. I'm going to grab the input shape, which I always think looks like an upside down guillotine. I don't know what other word we could use for that. But, you saw me wear my Guy Fawkes mask last time we were here. So, I've always got guillotines on my mind. And so we'll say input value. Now, that's kind of like annoying because we haven't really told people what they want. So I need to do a display shape, right, to tell them what I want from them. So I'm going to get to this, put in the display shape, which I call the price tag. See how when I drag it over, it tells me what it is? And we're going to call this, say, what number. Well, I'm not going to use the full words because, again, it's a flowchart. Number for CPU to guess. Right? Just telling the user to enter something like that. Dink and donk. Now, the interesting thing, or one interesting thing, is that at least in JavaScript, and I don't know if this is true in Python as well, you have one line of code to take care of both of these things. Is that true of Python too?
Yes, it is. It's input, which does the display and the storage.
Yeah. So if I were to write the JavaScript code, it would be var value equals prompt input number for CPU to guess. Dunk dunk. This is what the code would look like, and it's really quite a complicated line here because in one line we're dealing with storage, with input, and with output. All right. So, helping on the one hand, the flowchart is helpful to break this line down for students. On the other hand, one wants to indicate that, hey, you know what? Normally, that whole idea that every one of these things is its own line, that's not necessarily true in this case. So what I do is I grab a shape. This isn't from the flowchart set, so it doesn't automatically have a word in it or anything. I put the shape over these two lines just to indicate to the kiddos that it's not going to have a background color, but I'll give it a line color and maybe a little bit of a thicker value of line. And that kind of lets them know, what, these two shapes, they're one line of code. I'm going to just move that to the back. Okay. So is there anything else I can say about how I do this? The first arrow that you connect out of a decision shape is always the S. That's an important thing to know.
Again, that's not something I was ever consistent with. If you don't mind, Bram, I'd like to, at this point, also say that one of the reasons I love flowcharts so much is because it really branches the ability spectrum. And especially where I would do this sort of lesson in my course. Students were often better at doing flowcharts than they were at writing the code. They weren't quite at that stage. They'd internalized all the logic and the flow as Bram and I have. And our flowcharts naturally look more like code, I think. And I think we talked about this previously, Bram. Our flowcharts look more like code because we're used to thinking in that way. A student, a student just getting to grips with it might not have all the same boxes. They might have something simple like start, go through each value in the list. Is it the right one? Yes or no? It might be something as simple as that. But what that means is you can start getting them to break it down. Once those initial ideas are there, exactly as Bram's done here with that first box and breaking it into two new sections, is we say, right, well, there's steps to this box. How do we break it down? Let's expand it and let's do a bit more with it. And actually, the flowchart lends itself better to working with a wider range of students, and especially students that are not as familiar with coding as you'd like, because they can express it simply. If you start, apart from GPT-3 and Ghostwriter, you can't really express code in terms of go through all the items in the list, please. Although I suspect that Ghostwriter and GPT-3 would give us working code for that.
I actually just for fun today, David, I said, could you please show me a flowchart for a quicksort algorithm? And it couldn't do it. That was too much for it.
I've actually got a video sitting half edited on my hard drive. I say hard drive like I'm from the 50s or something, on my SSD, where I've gone through a British GCSE computer science exam and got GPT-2 to answer the questions. Which is quite fascinating. It failed completely at flowcharting, anything even remotely visual. I even got DALL-E up to see if it would do the job for me, but no, it didn't. It was too artistic. But spoilers, the grade it got in a GCSE computer science exam was a B, which I think is incredible. So it is definitely going to change education.
I was on DALL-E today. I said, show a picture of a bald, bearded man looking into a reflective pond as drawn by MC Escher. And oh my God, it was so amazing. Anyway, Tony's got a question for us.
Yeah, Tony said, is it easier to have blocks all the same shape and use words like display and get rather than specific shapes? I mean, if you don't mind me taking that first, Bram, because, at the British exam board, we have specific shapes. I'll just jump back to where I was in my slides and swap over. The shapes that we use in the English Welsh exam system are specific and they need to be replicated. And to be honest, they are easier. We use the rounded rects for terminators, start and end conditions, the rectangles for processes, decisions are diamonds, subroutines are those boxes that it lines on. And if we need to go to a different part of the diagram, we just put circles with numbers in. There's not much more to it than that we need to use even at A-level in the UK. But it does make designing it quicker, I think. I think it's easier to have boxes with meaning than having to write the meaning. If you're going to write the meaning, you might as well write pseudocode as far as I'm concerned. What do you think, Bram?
Well, if you go back to my screen, I've just dragged the boxes off without writing anything. And you can see them on the left. That's manual input, that's decision, that's display. They're exactly what you just said. This says predefined process instead of subroutine or whatever, but it's the same thing. So I don't have to, when I do a decision, I don't have to say if, because the word if is contained in the fact that it's a decision shape, right? I don't have to say display or show in the display shape. That's what the shape actually means. I can just put a variable in my manual input. We know that it's manual input. So yes, the shapes convey the thing that the words would otherwise convey, and therefore we can minimize the number of words once students understand what the shapes are. And we can use flashcards to get them to understand the shapes easily enough, or just have them build any kind of a process at all with shapes. Like, one of the early things I give them is, make spaghetti and show me in a flowchart how do you do that, right? Well, you got to throw the spaghetti on the wall and see if it sticks, right? So does spaghetti stick? Yes, no, right? So yeah, Kids really like flowcharts, I find.
Mm-hmm. I also think it's my students forever would forget all the symbols. They'd remember half of them. So I would just have one display board with a flow chart on it for something silly like how do you make spaghetti, how do you make a cup of tea, something like that. You know, how do you prioritize whether you do your homework or whether you play on Xbox, something something like that. And then the symbols are always there. So students were constantly in my room just looking at the same board all the time. And that's what I found worked okay. Tony said that the Scottish government use standard shapes and structure diagrams, but they have a choice of technique and never need to use a specific approach. That's true in Wales as well. They say design it and don't necessarily always explain whether you do pseudocode flowchart or actual code. But I do think there is a big benefit from just knowing the shapes. And there's not that many of them that they need to know, really. So I think it's well worth it. Computing FHS says, I find a few pupils use the correct shapes, normally just draw a box and writing it. Is that your experience as well, Bram? Do students try to get past?
No, well, I teach them flowcharting before I have them use it. Right. So like the first program I was just having my sixth graders learn today, or over the course of this last couple of weeks, is knock knock joke programs, because kids like knock knock jokes, right? We say, well, what's the first thing that has to happen? Well, the computer has to say knock knock. Okay, is that input, output, processing, or storage? It's output. Okay, which of these shapes is output? It's display. Okay, so we've got to write knock knock in a display shape. I mean, we build it that way. I don't want to give them too much latitude in learning the language. I want to give them the latitude, as I think the other fellow on this thing was just describing, in how they build with it. What they design with it. But the language, it's very beautiful. It's very simple. We're really only talking about 5 different shapes here, right? I mean, you don't really need a whole lot more. There's the Terminators, the stadium shapes, but they're not really that important. So yeah, let them learn the shapes.
And also, if you have the opportunity to teach them anything computer sciencey at a younger age, like we would have, we'd have an hour a week when they were in like 6th grade. That's a great time to teach them this stuff, because those that are not as interested in the subject, because they're not going to take it later on, and they can still engage with this and they can still have a bit of fun doing it. I'm going to move us on a little bit, Bram, because once we've got that code, once we've got that flowchart, one of the things that we like to do is get them to actually build something. And so I'm going to build from this flowchart. And I know this is a bit weird because I've written code, you've made a flowchart from it, and I'm writing code again. But I wanted to show, as an example, I've left Ghostwriter turned on to show you why it's the ultimate tool for teachers, honestly. I was on the beta of this when I was still in the classroom and still in front of the kids all the time. And I saved myself so much time, especially with these topics. They're fantastic. So one of the nice things with Ghostwriter, and it's an AI system, it's $10 a month, but it really is worth it, honestly, is that you can just start typing and it will pick up from your context what you want to do. Now, lazy man's way of doing it, Bram, is to do this. Then I just press tab. It's complete. It's quite cool. So there is a linear search algorithm written in the best part of a second. But the reason I do want to show all our teacher friends out there how great this is because it's a paid for feature. So your students are very unlikely to use it. And we are working on features that would flag it up if they use it in your lesson. So you can tell when it is. As it stands at the moment in history, that just looks like a copy and paste. So it's very easy to see, but we'll flag it up more for you as we develop this feature. But for you as teachers, it is a brilliant thing to have, because imagine that we've talked about linear search and you think, this student's doing really, really well. It would be great if I could knock up a quick binary search algorithm for them to see. Well, how long is it going to take? As long as it takes me to press the tab key and check that the code looks all right. And we've got binary search. Now, Ghostwriter works particularly well for all the classic algorithms. In fact, you could even go one better and do def bubble sort. And when I go into the next line, it'll start suggesting bubble sort algorithm stuff for me, which, again, if you've ever had to teach these things, it is an enormous faff to consistently be building algorithms like this. And I used to have just a sample of code in a folder that I'd copy and paste. It's so much nicer to do it live. But when your student's building from the flowchart, have you got the flowchart up, Bram? Yeah, let's jump back there.
You want the binary flowchart now?
Yeah, if we flip over to the binary flowchart. So the binary flowchart's quite nice as well, because what I would normally do is, I'm going to pop back to mine in a sec, Bram, is I would then go on after looking at linear and seeing why it was rubbish. We'd look at those people, I say rubbish, it works, doesn't it? But we'd look at those people that were using Bram's method of going halfway, and we'd say, well, that's actually a thing. You know, a binary search is actually a thing, but it only works on an ordered list. And Bram and I were talking about this the other day, actually. It's whether you invest the time on sorting the list in the first place that's important. But I showed an example like this, and I never go into too much detail with it. I just show it working. And I show we find the midpoint, and we ignore the half that it's not in. We find the midpoint, and we ignore the half that it's not in. So worst case scenario with a set size 6, it's going to take me 3 moves. But I'm removing half each time. And that very quickly lends itself to building a beautiful flowchart like Bram's built here for us, where they're thinking about how that's going to work, and they're thinking about which side it is and tracking pointers.
I just want to point out to people that you'll see that in Lucid, you have different tabs. So that's not only useful in terms of making a progression of different flowcharts, but if you have a very complicated program with lots of different functions in it, you know, you do the main on the left, and then you build each of the functions in all the other tabs. Leave a tab open. Don't put anything there, and have the students flowchart that particular function onto that one. So it's just, anyway. I don't get any money back from Lucidchart. I'm not hired by them like you are hired by Replit, but still, it really is a lovely thing.
It's really nice as well. Like Lucidchart is what I would use for my flowcharts with my students, because it's just nice and easy, and you don't have to worry about them getting the connectors all overlapping and freaking out about it. It's nice. So after building the flowchart, you know, it's a relatively simple job then to build that algorithm and sort big sets of data. One thing that I would suggest, though, again, Ghostwriter is great for this, but write a function. Show them how to write a function that records the time at the start of the sort and the time at the end. It's very, very easy then to show them the difference of how long it's taking to sort these things. And I did say, Bram, that we'd look at a YouTube video, didn't I? That I've just realized that I've forgot to put in this deck. So I'll try and dig it up when we're having a chat about something else in a minute. But one of the things that I often talk about, and I've got this up here, is the big O notation. Because one of the things Bram and I talked about when we were discussing this workshop is just, how do we decide whether it's worth us sorting the list in the first place if it is unsorted? And that brings you on a very, very nice and easy discussion on why big O notation is important. And big O notation, again, these are just my teaching slides. Big O notation is useful because it allows us to talk about how complex an algorithm is without us talking about things like time or space, things that can be changed by faster processors or more RAM or more storage. So this is all I ever talk about with big O. My students at A-level have to look at some code and determine what it is. But we go from the fastest to the slowest, and we look at O1, which is a constant. That means it always takes the same amount of time, and that might be a push or pop on a stack. Then we got logarithmic, and we assume the log is log 2 all the time in here. But as the size of the data set increases, the number of operations only increases by a smaller and smaller amount each time. And that's what binary search is. So logarithmic is the second best case, really. There's a weird one in here because our exam boards have 2, or at least my exam board had 2. Linear is okay. It scales completely proportionally with the size of the data set. So if you've got a data set with 10 things, it might take 10 operations. If you've got a billion items, it miit take a billion operations. And that's our linear search that we just built. And you can see there, students very quickly go, oh, I see. Yeah, that makes sense. Then we've got n log n logarithmic. I'm sure that's got a better name, but this is what our exam board called it. So that's what we always used to stick in there. And it's where it is logarithmic, but it's got a multiplier by the set of the data. So Quicksort is an example of this. As the data increases, it does increase a little bit more than linear. That's all it is. And then we're getting into the bad ones. Polynomial, n to the c, where c is just a number. So the data set size squared, the data set size to the power 5, something like that. That gets long or big very, very quickly. Selection sort is one of those. And then you've got worst case scenario, exponential. This is like the traveling salesman problem. The data is actually the exponent. So it increases the complexity normally. And please feel free to steal my slides. I'll share these with you if you want to. It's a nice way of talking about it and showing it and getting those conversations going. Now, normally this is right at the top end of the age groups that I would talk about this with. But it's good to have those conversations because we can start to put the flowcharts in terms of, well, where do you think they sit? Where do you think they're working? And in Bram's flowcharts, if we can bring them back up again, Bram, show us the difference between linear and binary. Now, I'd say that linear search actually has less components.
Well, I mean, the main component is how many decisions are being made. Mm-hmm. Linear has 1 and binary has 2.
So this leads us to another question, because although big O is important, it's not the most important thing in the world. Sometimes it is the logical complexity of something, and a linear search algorithm is simpler for a human to understand. And that's a big part of, can we build it properly? I think there have been loads of issues with certain blockchain implementations because the algorithms are so difficult for humans to keep in their heads that bugs creep in very, very quickly. And if you're building something that's a bit too difficult and you have to build multiple copies of it by different people, then bugs creep in and you lose security hashing. You find yourself in a position where people can take the contents of your cryptocurrency wallet and just take it for themselves via a little bug. So that leads to a really good conversation you can have with your students about whether it's worth overthinking the thing and making it really logically complex to get it running fast, or whether it's worth putting less effort into thinking about it and making sure it runs consistently.
So this is a funny story.
Go on, Bram.
I have, a student that I've totally trained in flowcharts are wonderful, and she's making tic-tac-toe, but not in an object-oriented method. So she built all the flowcharts out, and then she coded all of it without testing anything.
Oh no!
So she's like, "Great! I've built the whole program. Let's go see." I'm like, "Have you tested it?" "No." "Undefined." "Oh no!" And Replit didn't tell us exactly which line the undefined was being triggered by, because that's not in Google. In what's the name of the backend that everybody plays, that all these browsers use? There's a particular JavaScript engine. Chromium, is that a way? Yeah. Anyway, yeah, we were in Chrome, but it doesn't matter. So whatever it does, it wasn't able to say exactly what line. And then I said, well, wait, Replit must have a debugger. And we looked there, but of course Replit didn't, in our search, have a JavaScript debugger. It had a Node debugger, but not JavaScript. So we had to basically start going in and, sticking in a bunch of flagging alerts to try to figure out, how far we were getting. Oh, but it was definitely a good lesson to learn that, you've got to code in chunks with stubs.
I think that's true. One of the things we did with 100 Days of Code was we got to about day 15 or something, and the project started getting difficult. So especially for new coders. So we decided to start doing a series of videos of just me making the solution. And I was very, very keen to them just be a recording of me doing it. I sped it up when I was just staring at it and scratching my big old head, thinking about the problem. But it's everything in there. It's my mistakes. And you can see me write 2 or 3 lines of code, test it. 2 or 3 lines of code, test it every single time, because, we are experienced in, you can't just, it's not like an essay. You can't write 20,000 lines and then reread it and hope for the best. It's logic. So it needs to be small chunks, doesn't it?
Absolutely. But there's such a feeling of power to have the whole thing flowcharted out. It's made her very comfortable. So we're hitting it. Last week she learned about how you always want to push your functioning iteration to main and push your non-functioning iterations to sub branches for saving stuff. So it's lovely little lessons.
It's great when you got You got those things built in, I think. So what all this leads to basically is us starting to talk about sorting algorithms as well, and things like bubble sort. And I think, Bram, we've got a flowchart for, what was it, Quicksort, I think, wasn't it?
Yes.
Yeah. So Quicksort is one of those things that's logically quite simple, actually, but is a bit of a pain to build. And for those of you that are struggling to remember which one Quicksort is, because I know that without my slides, I was never much good at remembering which was which. I've got a very quick reminder of Quicksort. But Quicksort is one of my favorites because you start with a says unable to click in the actual window. They're both it's nlog n logarithmic in time, and log and just logarithmic in terms of space complexity. So that's the amount of stuff it needs. So we start with a list, we split them up. So we pick a pivot point, and then we bring the items down either on the left or the right, depending upon whether they're bigger or smaller than the item. In this case, alphabetically, before or after. Once that's done, the pivot point is locked and it's in the right place. And then we take the sublists and we do the same thing again. We pick a pivot point for this. It's normally the left-hand side, and we put that where it should go. A is then locked. We do it with the other sublists. Pick F as our pivot point. E is going to go before it, and D is going to go before it. So again, there we've got another locked element. When we get to any element that's just one thing, a list of one is always sorted, so that can just lock itself. E and D, we'll use E as the pivot point. E goes there, E is locked, and then finally D is the last man standing. Doesn't need to happen. Nothing needs to happen to that, and you end up with a great sort. Quicksort does what it says in the tin. Fantastic, and you can see that actually, in terms of flowchart, it's quite straightforward to talk about. And I really like this flowchart, Bram, because it's I think Quicksort is one of those things that makes a lot of sense. You show it to the students and they go, "Oh yeah, that's sensible. Yeah, I can see how that works." But the problem comes when you try to actually build the thing. Because actually keeping track of those pivot points, which things are sorted and which things are not, becomes a job in itself. There was an exam a couple of years ago which asked students to write a Quicksort algorithm from scratch, and our A-level exams are paper-based, so it was writing pseudocode for it. Now, they could have written a flowchart, and many of my students did. Those that did a flowchart got almost full marks. Those that attempted to write pseudocode, not so much, unfortunately. So, I always encourage the use of flowcharts. And I do just want to show one more thing, because as great as Lucidchart is, and it is great, sometimes you just want to do a quick and dirty flowchart with someone. I've shown you this before, but we've updated it this week. A draw file. You make anything, literally anything, .draw in a REPL, and it creates an interactive whiteboard for you. Now, we've updated it so you can include images now, but it also has a lot more symbols. So we haven't got masses, but you've got enough to be able to start your way with a flowchart. And it's a very, very easy way. And as long as that REPL is multiplayer, I can pop the invite, actually, why not, in the chat. Come and have a play with it. It is a very, very simple way to do a quick flowchart. I certainly, in my teaching career, found that quickly flowcharting something to explain a concept to a student was really, really powerful. Bram is a big proponent of this, but a student stuck on some code, rather than explaining why the code's not working, quick flowchart. This is what you're doing. This is what you think you're doing. And they can easily see the visual difference there. But by doing that, it's in the REPL that you've probably got access to anyway if you're using Teams for EDU. It's right next to the code, so the student can pull it out. And of course, with our new interface, we can pop that on the side over here, and we can bring the code up wherever we want it to go. So pop that over here. Here we go. So we can have the interactive flowchart now right next to the code that we're working on. And it's just a really nice way of working, because the multiplayer means that you can go in, mess around with the code, and also move things around and do a quick discussion. It isn't on the level of Lucidchart for building complex flowcharts, don't get me wrong. It's always good to go there if you're doing that. But for a quick, dirty, here's a note between us, here's some design documentation, it's great. And now that it supports pictures, happy days, because you can actually bring in images of user interfaces and things like that, and backgrounds and tables and things that you might want them to work on, which is,
I wonder, David, would it be possible to build an iframe into this interface so then you could actually slap the Lucidchart into one of those little windows?
Well, I'll give you a bit of a spoiler, but if you remember the tutorial feature from 100 Days of Code, but that actually will work as an iframe in the floating video window. I'll just pull up on the Learn page now. We're having a lot more content of stuff that students can work through on their own. And the winning one happened to be sorting algorithms. But what they did is, instead of using the video frame as a video frame, they used it as an iframe, and they've embedded this HTML view here. So as you're learning about sorting algorithms, you can interact with a web page, increasing the speed, generating new data sets, and watching it sort as you try and build things. So that is very easy to do as well. If I show you the code for that, if you've not used the tutorial feature, by the way, there's some docs that we have, but it's basically a folder called .tutorial, and there's a video.json. I say that weirdly, don't I? It's JSON, isn't it? And all you need to do is, instead of putting a video, put a website address, and it will work as an iframe. And more than that, it'll float over the top. So I've never tried it with Lucidchart, Bram, but that might be something to have a play with. Also, I'm now suddenly thinking I could probably put Chat GPT in there, couldn't I? And that would be...
And then your students don't have to worry about not paying for the companion or whatever that's called. They can just use the OpenAI to do it.
Well, exactly. Yeah. I would say teachers get Ghostwriter. It's brilliant. But yeah, for the students, as they're looking at it, I will just say sometimes when using Chat GPT and you're trying to put code in, it doesn't always give you the full file. I find it very frustrating when I was dealing with, what was I dealing with the other day? TypeScript. And I was going, I don't know anything about TypeScript. And I was trying to build some pages. And I was going, how might I do this? And it would go, this is how you do it. And I paste the code in, it wouldn't work. And I'd get Ghostwriter, and I'd right-click, and I'd go transform code, and I'd say something like, oh, fix this. And it was missing about 6 lines, but like instantiation lines and stuff that I suppose if you knew the language would be obvious to you, but I didn't know the language. So it was great for helping me out with a chunk of code, but it wasn't giving me full working files in that particular language. But I suppose it just depends on what it's trained with. But here we go. It's not really meant to be a code helper, is it? It just works really well as one.
Is it a linting tool as well, Ghostwriter?
In terms of
like, hey, my thing isn't working, tell me why?
It works. There's no discrete function for that, but you can use transform code, which is you highlight some code, you right-click on it, transform, to just say, fix this, please, or stop this erroring. And it does a quite a good job of restructuring it to remove those issues. So yeah, really? You can use it like that. Again, it's not a feature that we advertise because it's not something that works 100% of the time. But I've had a lot of good success by doing that myself, especially with languages I don't understand. Just highlight, fix this, please, and then it does a good job of giving that a go. But the tool, really, the transform tool, is for changing code. It's very good as well, changing from one language to another. Especially, like for me, it was very good. I can write something in Python in 3 minutes, but I wanted it in TypeScript. So I'd write it in Python, highlight it, transform, and go, TypeScript, please. Boom. The component would be there. Same basic structure, but different language. So, it works really nicely. It's really nice for learners as well, because there's an explain code feature, which works beautifully. I've got a video series coming out on this, hopefully on Friday as well. So if you fancy finding out a bit more about it, go have a look in the Learn Hub on Friday, and it'll be there. But yeah, it is really, really cool. I wouldn't do dev work without it anymore, because I feel like it's my little pal helping me out. One thing I said was, I'm a big PHP fan. It's just me and Mark Zuckerberg. I know, Bram. It's just the two of us, but I'm a big PHP fan. But there's a syntax that I can never remember, and it's the for each loop. And it's basically a Pythonic loop. It's a loop where it copies the data into each instance rather than having pointers to it, which works really nicely. It's such a weird function. I think it's written backwards or something. I can never remember. I always try to write it, and I do it the wrong way around every single time. Ghostwriter means I start for each, and it goes, bloop, and finishes it off for me. So I haven't had an issue with that in a couple of months now. So all good. I feel like I'm doing the hard sell. Honestly, it's great. It is really good. Bram, we are at time more or less. Is there anything else you wanted to chat about before we say goodbye to everyone?
Well, trying to remember the Quicksort algorithm, sometimes difficult. You might even say Quicksortic.
I laughed this much last time he told me this joke as well. It is. You said steal it, Aaron. No, too good.
I didn't know what else to say. Anyway, thanks again, David, for enlightening me as always to the infinite power of Replit, and I'll have to go and try it for that linting technique when I get off the call.
Yeah, I think we're slowly rolling out, and it's not going to be to everyone soon, but we're slowly rolling out a self-service trial as well, because it's been like on a waiting list for a while. So you might find yourself in the flag for that at some point. So cool. If you want to give it a go. Otherwise, it's $10. It's well worth a go. It's well worth a month of pay just to see how quick you can knock things out. But Bram's entire thing is that flowcharts absolutely rule, and I am with him 100%. Bram, thank you so much for doing these 2 workshops with us. I've loved every second of it, and I think our audience have as well. And hopefully everyone watching async, hello to you, will be enjoying it as well. But Bram, is there any way we can go to find out more, or to contact you if we need to? Or are you going to be an elusive?
I don't know. I feel like what I've presented is, there's a billion Lucid tutorials. If you ever want to look at those, they have lots of videos. They're wonderful. I don't have a next step, but this is great. I'm going to be working. I'm working on a workshop with a friend of mine from Canada, Mike Deutsch, on the concept of sense making, which is a much broader picture than just coding. My other hat is looking at fake news, misinformation online, and how can you tell the difference between here's something I can trust and here's something that I can't. And sense making applies to both of these things. But I just think that flowcharts are a very good tool for helping students make sense of code, because if you just put code in front of them before they've done this piece, it's hard for them to model in their heads what everything means. But anyway, that's one other thing I'm up to. David, thanks so much.
Thank you. And when you've got that going, if it's publicly available, send it to me and I'll tweet it out so everyone else can find it as well, because you're a lot of fun, Bram, and I look forward to seeing your next workshop. Thank you very much indeed. But as it stands, we've had a great time. We hope you've taken something useful away from this. We love flowcharts. Hopefully you do too. And the hard sell, Ghostwriter. Don't make sense. I'll stop that now. I'm starting to feel a bit icky. But thank you once again for tuning in to our No Assembly Required pedagogy workshops. We'll have another one in January, which I've not sorted out yet, because I think we'll sort it out once we get past the holidays. But we'll see you all there.
Use the Quicksort algorithm when you do, right?
Absolutely. Thanks so much, everyone. We hope you have a great day, evening, wherever you are in the world, whatever time it is. See ya.
Peace out.